Dear all, I would like to welcome you all in the lecture series of training on competitive examination. In this session, I am going to discuss most important concept for the competitive examination, especially in the assistant engineer level. So I'm going to discuss one of the important topic in analog electronics, that is PN junction diode. You know what is PN junction diode? It is a combination of p-type and n-type semiconductor material that creates a potential barrier across a junction. So that is basically called a PN junction diode. So there are two type of condition: PN junction forward bias condition and the PN junction reverse bias condition. Similarly, forward, if it is a silicon diode, if the PN junction is made up of the silicon diode, then the forward voltage drop will be 0.7 volt. Where if you are making the PN junction with the germanium, then the forward voltage drop is 0.4 volt. Also, as you apply the reverse voltage, then the junction is going to break. Definitely, there is a movement of current that is known as leakage current. Okay, the current which is flowing through the once you apply the reverse voltage or negative voltage is called as leakage current. So usually the leakage current is expressed in terms of nano ampere in terms of silicon material. If it is germanium material, the leakage current will be expressed in terms of micro ampere. This point you are supposed to remember. Fine. So once you understand the theory properly, then you can easily appear the multiple choice question, especially in the competitive examination. Now you can see one important diode equation. So as you can see, the diode current, you can easily calculate the diode current by using the formula I is equal to I0 into e to the power EV by KT minus 1, where K is known as Boltzmann constant, the value is given. Similarly, VT can be calculated. VT. Okay. So VT is nothing but the KT divided by Q, where K is known as Boltzmann constant, Q is the charge of single electron. Okay. This point you are supposed to remember. You may get a numerical example based on this particular equation. One more important point I want to add. Here you can see one term called eta. Some textbook they mention like N. The eta is known as ideality factor. So when it comes to the ideality factor, please refer this particular point. For germanium semiconductor material, if the diode is made up of the germanium, ideality factor is equal to 1. Suppose if the PN junction diode is made up of with silicon, then ideality factor will be 2. This can be asked in the examination. Fine. So what is the value of ideality factor if the diode is made up of with silicon? They may ask like that. Next is actually junction breakdown. So how the junction breakdown occurs? Once you apply the reverse voltage, definitely there is a movement of reverse current. Definitely because of that, junction is going to break. So this is basically called a junction breakdown. Similarly, one more term called the Zener breakdown. Okay, if I talk about the Zener breakdown, this is mainly occurring due to the heavily doped condition. So depletion layer is too narrow. Moreover, a strong electric field is generated. It is around 10 to the power 8 volt per meter. So that because of this reason, the Zener breakdown takes place. One more type of breakdown is known as avalanche breakdown. So this is actually the particular, if I talk about the junction, it is lightly doped, but the depletion layer is wider. So the electric field is weak. These are the peculiarity of avalanche breakdown. Now we'll discuss about ideal characteristics of diode. Okay, so diode characteristics, you can initially you have to consider the normal characteristics of a diode. As we can see, there are two characteristics. This is actually called a forward characteristics. As we can see, this is our silicon diode, and where this is our germanium diode, germanium and silicon. Okay, this is voltage is known as knee voltage. Okay, forward voltage or knee voltage you can able to mention. When it comes to if you apply the reverse voltage, then we can, as we can see, the diode is actually getting ruptured, because if you apply the reverse voltage, it will conduct in the opposite direction. That means the diode is the property of the diode is getting destructed. So diode will always operate in the first quadrant. Third quadrant, the diode never operates in the third quadrant. That point you have to remember. So another one is actually one of the probable questions in the most of the competitive examination. That is, what is an ideal diode? So if I talk about ideal diode, zero resistance when it is forward biased and infinite resistance when it is reverse biased. So, but these two conditions are only ideal, but in practically this never be happened. Okay, this point you are supposed to remember. Also, I can draw the ideal characteristics of a diode by using this particular characteristics. This is your current, fine, and we can see the forward voltage and reverse voltage. So no current, that means at the reverse bias condition, the resistance is infinity. At the forward bias condition, resistance is zero. That is the meaning of the ideal characteristics of diode. Actually, ideal characteristics never be possible actually. So these are the fundamentals of PN junction and diode. Fine. So I'll be discussing a few questions based on PN junction diode in the next session. So we'll go through the theory part. Later we'll move on to the MCQ question. So in this session, I discussed about the brief information about the PN junction. What is a PN junction? What is a semiconductor material? And what is a forward voltage drop of silicon diode? What is a forward voltage drop of germanium diode? And the leakage current range of silicon and germanium separately I have discussed. Also the diode equation. So there is a one diode equation. In that there is one terminal called N or eta. Some textbook they used to represent like N, or generally eta or N. Both are fine. Then eta is varied with respect to the material. Eta is known as ideality factor. Also, junction breakdown I have discussed in brief. What is the Zener breakdown? What is the speciality of Zener breakdown? What is the feature of avalanche breakdown? Then ideal characteristics of a diode. These characteristics you need to remember. So these are the important points I discussed in this session. If you have any queries regarding this, only a brief points, kindly note down these points in your separate notebook, which you are going to prepare for your competitive examination. Thank you so much for watching this video. Happy learning.